So welcome to part 2 of our laser project. In the last video we basically wrote a whole bunch of facts to create this laser beam bouncing around in our scene, and now we just want to make it pretty. Also, if this amount of X is scary to you and you just fine with one single straight line for your laser beam, you can also skip all of this and just follow along for today. There is no additional things in here that you need to complete this setup. So let's build our setup right here. And first of all, I want to take this single polyline of a laser beam and turn it into geometry. And for this, first of all, I want to subdivide this a bit further. This is something that I needed to do to get rid of some shading issues. And for this, I want to use a resample node. And let's resample it to a somewhat smallish value, 0.02, like this. Then let's also get rid of some attributes, specifically our normal attribute, because this is going to interfere with sweeping this later. So let's just get rid of the normal in here. And then finally, to turn this into geometry, I'm just going to use a sweep node like this. Set the surface shape to round tube. Let's also get rid of all the little helper displays in here. We don't need them. And I want to turn the radius down to 0.004. Which at least to me was the right thickness of the laser beam in the scene. Now the last thing that I want to create for my laser beam is some UVs for texturing later, because to make a laser beam visible, we usually shoot it to some smoke in our scene. And typically this is something you can do with some noises. However, within Houdini we now have also a very fast 2D fluid simulation, which we can maybe use to put again a sort of smoke texture on our laser beam right here. But first of all, to do that, we again need some UV coordinates on the laser beam, and for this I want to use again a point wrangle, but this time a very simple point wrangle, where all I'm going to do is I'm going to set my v at UV attribute to a vector that I'm going to create from my position v at p and the x component of that, v at p.x, and also the z component, and then simply 0 as a last component like this. Now we already see the UV grid. However, this becomes a bit more clear if we take a look at the UV viewport as well. And the UV viewport, as you can see right here, is just simply a flat version of a laser beam. And this works fairly well once we simulate also a flat sheet of smoke to sort of give the illusion of this laser beam passing through some thick smoke in our scene. And once I'm done here, I'm going to grab a null that I created earlier, this one right here, and this is already linked up to a karma setup that we're going to talk about in a bit. Let's also work on our optics table, because in the last video we disconnected the base plate of our optics table, so let's just connect it in again. This looks better now. And now the last thing that we need to create is the texture of our smoke. And for this, again, since we now have a new version of Copernicus and some very fast 2D fluid solvers in there, we're going to do that in a CorpNet. Let's jump inside. And inside that CorpNet, let's maybe rearrange our view in here, maybe like this. This is a bit better for corps. I want to use the new flow engine like this. Now, this flow engine needs some inputs, and I'm going to build the inputs from a bit of noise. So let's plop down our first of many fractal noise nodes in here, and I'm going to just leave the default values in here. I'm fine with this. Now I also want to have some sort of smaller particles in this initial noise field. So what I'm going to do is I'm just going to drop down another one and simply make the element size a lot smaller, 0.001. And then I want to blend them together with a blends up. And then put the blend value at maybe 0.25. So now I have some graininess in the main noise. And let's also make it a bit more contrasty by dropping down a contrast node, firing a noise in here and setting the contrast maybe to 1.6. And now this can go into the color field. So this is the texture that we're going to displace with our flow solver. Let's try this out. If we hit play in our timeline, for some reason the solver is still complaining, but it should already run. However, we don't have any forces currently in our scene to displace the smoke, so it's showing absolutely nothing currently. To move our texture around, what we do need is a velocity input, and this is something that I again quite easily built from yet another fractal noise. And yet again, just default values. The only thing that I changed is the roughness, and I turned this down to 0. And then from this noise, I want to calculate a direction, and I can do this with a slope direction node, where this in here, and now I have some directions that I can plug into the velocity of my fluid solver in here. Now if I run this, hopefully, yeah, we should see some smoke curling in here in our scene. The only thing that I currently want to change with this setup is that this is fairly slow and fairly small. So to change that, what I want to do is I want to go to my slope direction and turn up the strength of my forces to 10. And yeah, this is now looking a bit more beautiful. Now we can take our color value in here and again turn it back to mono, RGBA to mono like this. And the values in here are fine. And then we can turn the contrast up even more with a remap function. And the main thing that I did in here is work on this right here, this ramp, and I simply selected both of them and turned them into, I think, monotone cubic, and then just pushed the ends in a bit like this to get this nice and contrasty. And at this point we can sort of preview this on our laser beam. To do this we can use a SORB import and import our beam null like this. And now we can get a preview material and our beam goes into the geometry. Then this remap should go into the opacity. And to turn this into a laser beam, what I want to do is I want to go to the emission parameter and turn this up and turn the emission color to red. And let's also go up to the main color, which I think is this one, and make it red as well. So now if we turn off the UV display and take a look at our texture on our beam, we can sort of make out the smoke going through a laser beam. And now to use this in our shader, let's move the preview material out of the way. And instead, let's drop down a ROP image output to save this out as an image sequence. And to do that, let's quickly switch our parameters around again, like this, so you can see it a bit better. And with the ROP image selected, I just want to drag in my reweb node into the core path in here. And I want to save this out as a frame range. I don't need this to have a ton of data, so let's simply save it out as a JPEG. And let's also maybe change the output directory to text. And since this is an image sequence, let's also put it in a folder called smoke. And let's maybe just call it smoke currentframe.jpg. Then let's set up the export. Let's go to the color space conversion and simply set it to raw, since this is just simple opacity values, and all the rest should be fine. So once you have set all of this up, we can simply hit render to disk and get our image sequence of our smoke, which is something that I've already done before creating this video. So we have our mesh, we have our textures. So now let's jump into Solaris and into Camera and let's take a look at rendering this. This right here is the Solaris scene. I first of all in here have a SORB import for my entire scene. So this is my mirrors, my prism, my table, and all the little thingies that are holding all these things up. And all of these are separated using a name attribute. And then I also bring in my laser beam like this. Hopefully you can make this out as well, this bar right here. Then this goes into a material library, and I have most of them already set because these are really simple materials, just the default PBR workflow. The main thing that I'm interested in here is my beam material. And for my beam material, what I want to do first is go into the base color and change this to red in here as well. Then go down to the emission and again set the color in here to red. And also turn up the strength of the emission to, let's say, 5, a pretty strong emission. Then I also want to set the opacity on the one hand with the texture that I created, but also I don't want to have a solid laser beam like this. I want this to sort of fade out to the edges. And for this I can use a camera fall off like this. And if I plug this just as a test simply in the emission color, let's maybe turn this back down to 0. You can hopefully see that the edges of my laser beam are just shaded a tiny bit darker. And maybe I have to go into the rendered view to actually see this. Switch to Karma XPU. And yeah, as you can see, these are a tiny bit darker. And if I play around with the gamma value, hopefully they're getting also a bit darker as well. But let's leave this at 0.5 and let's not put it into emission. Oh, and I should of course put emission to 1. Now let's hopefully see this. Let's maybe again put it into the emission color. Yeah, and now you can hopefully see with those debug colors in here at the edge we have this red color and in the middle we have this green color. And if I adjust the gamma, I can sort of adjust the shape of our beam or the thickness of our beam. But again, I don't want to plug this into the emission. I want to plug this into the opacity and I want to use the fall off value. Let's plug this in here and play with the gamma value, and I can sort of fade out my laser beam in here. Let's put the emission back to 5 again, and now let's bring in our texture as well. So this will be a Material X image like this. On the file name, I want to load in my smoke texture, so this hides under the tags folder in here. And let's pick the JPEG sequence that we have in here. And this node will complain because this channel right here depends on time and you can't have that with standard Karma materials. However, we can easily fix this by jumping back out to Material Library and make sure in here that we check Allow Shader Parameter Animation. The node will still complain for some reason, but it will work. And then finally, I want to use a Material X multiply to multiply both of them together. The one thing that I want to change in here is I want to change the texture type to float because this is just one single value. And now we can plug this into our opacity. Now taking a look at our laser beam, we now have again our smoke texture in here. This is all we need to do for our laser beam. Let's maybe take a look through our camera to see the entire scene. And as we also need to jump to the last part of our Karma render setup in here. I also just have a camera and some lights lighting the scene right here. And yeah, this is the end result that we have in here. So now to render this out, this is all fairly standard with just one part that we need specifically for the scene right here and for post-processing. Let's switch this back to our view in here. So on this Karma render settings node, I first of all set my resolution. I also set a probably too low count of path trace samples, but in the end this worked still fine for me. And then on the rendering tab, on the limits, these amount of samples gave me quite a few fireflies and I could get rid of some of them at least with this color limit. And then in the image output, to get rid of all the fireflies, I simply turned on the denoiser as well, and this worked fine. And in the metadata, since I want to render out EXR files, I turned the EXR compression to DWAB to make my EXR files sort of the same size as PNG files. And the reason that I want to render EXR files is that I want to add some glow to my laser beam later as well. And to add that glow to my laser beam, I want to have one extra AOV in my rendering. And that extra AOV hides under lights and emission and is the direct emission. And to quickly preview that AOV, let's jump back into our XPU viewport and let's use the AOV viewer in here. And if you take a look at direct emission, we just see the laser beams that are directly hitting our camera. So this is exactly what I want later for adding some glow to my laser beam. And at this point, you can just drop down a USD render up, use pretty much the standard settings in here to render the specific frame range and render it out as EXR files. Now quickly, for this entire rendering process, what I should add in here as well is if you want to do all the lighting and shading, make sure that if you right click this eye in here and turn on color correction, make sure that you're using ACES and that you set the correct display view in here. Because once you're doing stuff with really strong lights, if you use the standard settings of Houdini, you get really weird looking results, which are not desirable at all. And ACES makes them look just a whole lot better. And if this isn't set in your scene right here, you can simply set it by going to Edit, OCRO settings, and make sure that you're using these settings up here and hitting apply. Now finally, for post-processing my renderings, this is something that we can easily do in a CorpNet as well. So let's jump in our CorpNet right here and let's make sure that we're loading in the right renderings like this. This is something that I rendered out earlier, and let's maybe jump back to our build desktop. Let's make some room in here and let's go to the composite view like this. So this is our input right here, and this is our output right here. And if I turn on the output, you can see just a slight glow on all the laser lines, which I think is just needed for lasers. They just look off without it. And to get to this result, the only thing that we need to do in here, let's get rid of all this right here in the middle, is we need to import our EXR files where we render them out, and then also hit this button down here, add AOVs from file, and you should have one beauty pass called C and one AOV pass called direct emission. And again, the direct emission should be just our laser lines. And then to create our glow, what we need to do, let's make some more room in here, is we have to blur our direct emissions. Put down a blur in here, and I want to make the first one fairly wide, 0.05 maybe, and I also want to remap that blur to make it a bit sharper. just play around with this ramp down here. Let's maybe move this a bit more inward and drag this a bit down. I think this looks fine. And we're going to do this one other time, just this time with a smaller blur. So I'm just going to copy this in. Again, in here, the blur is a good bit smaller and the remap is the sharp remap that I created earlier. And then we can take both of these blurred lights and add them together. This will be our main glow. What I also wanted to do is to multiply them just with some noise to just sort of simulate some additional particles in the air. This will be another fractal noise. On the fractal noise, I turned up the noise contrast a bit, maybe 0.18, and the element size way down, 0.001, and then also turn on 3D noise and animate and set the pulse length to something fairly short, maybe 0.5. And this again just sort of looks like particles in the air, which I think adds to the effect. Then we can take our blurred lines and simply multiply our noise onto them like this. And finally, we can take the result from all of that and add it onto our main image. So let's zoom out a bit here. Let's drag out from here. Let's search for add and let's add a last node in here. And now if I switch between the before and after, as you can see, we have a fairly nice glow in here, and I can dial it in by simply playing with the mask in here, and I think 0.75 looks fairly classy. And finally, to save it out, again, another rob image output. If you want to keep working with that image sequence, if you want to keep color grading it, I would want to keep it as EXR files. Use an open color AO color space, and probably the best thing for grading CG images currently is the ACES CG color space. And the look is something that we're just going to leave at none, and then we're going to save it out as EXR files. In this case, however, I just want to go straight to JPEG because I'm already happy with that look that I have in here. So let's change the file name to JPEG. I want to have a proper JPEG conversion. Let's bake it to an open color AO display view. And we want to have an sRGB display. And we want to use the A 1.0 SDR video view, which coincidentally is the same that we have set in here. So our output should look exactly the same as we're seeing in here in our preview window. So this was just quickly the entire workflow for shading and rendering and post-processing this scene. I hope you found this interesting, and until next time, it's cheers and goodbye. And again, if you like us and want to support us, please also consider becoming a patron of ours as well and get 2 new extra episodes per month, and also all the extra premium episodes that we released previously all at once. And again, thanks to all our existing patrons. Without you, this channel would not be possible. Thank you.